Tenacious test 1, question 5. Here we are given another geometric series, 4x cubed plus 2x to the power 4 plus x to the power 5. And the first question is for us to determine the general formula with respect to x. So as you can see, the request was for a general formula. That's why I have Tn. And because I know this is a geometric pattern, I'm using the geometric Tn formula. Now, a is just the first term, so that would be the 4x to the power of 3. And they asked me to leave my answer in terms of x, and that's why you see there's an x there. I'm not trying to solve x or do anything fancy. I just have x in my answer because that's what's required. Now, the ratio is simply for us to now figure out how do we go from this term to that term. You know, what do we need to multiply with? And I can work that out by simply saying term 2 divided by term 1, or term 3 divided by term 2. However, I kind of just want to do it a bit more intuitive. Let's have a look at what's happening with these terms. So if you look at the numbers, we have 4, we have 2, then we have 1. So we're kind of dividing by 2 each time, or you can say we are multiplying by a half. And if you look at what's happening to the x's, we are increasing by 1 power of x each time. So if you multiply this by an x, you get that. If you multiply this by an x, you get that. So it's like we're dividing by 2 and we are multiplying by an x. So in total, we're actually multiplying by x over 2. Okay? The x is on top because you can see it's getting bigger, and the 2 is at the bottom because we are dividing by 2. Okay? But you can also do it in a much more elegant way, I guess, by saying term 2 divided by term 1, or term 3 divided by term 2, and you get the same answer. Cool. That's what I'm going to swap out for my ratio. My ratio is x over 2, and that is to the power of n minus 1. Again, I need the x there, okay, because the question was for me to determine the general formula in terms of x, and that's why I leave it like this. The next question asks us to determine x, or solve x, I guess, for which the series will converge. So we should know by now that a series only converges when the ratio is some number greater than -1 but less than 1. Also, the ratio cannot be equal to 0, because then we have a trivial series and we don't necessarily want that. So since the ratio was x over 2, I'm going to swap out that for r, and I'll just solve x by multiplying on both sides by 2. So this is -2 and that's +2. X will be some number in between -2 and +2, but x cannot be equal to 0, because if x is equal to 0, our ratio is going to be 0. Okay, hope you can see that. And that's actually why x cannot be equal to 0, because our ratio can't be 0. Okay, that's it.